If you're watching this video, you are looking at your second quiz of the year. It includes some of the material from our 2-column proofs. It has some bisectors, trisectors, and midpoints as well. The first question here, a proof is written for you. You've just got to fill in the blank with the appropriate reason or statement. This one may be pretty self-explanatory. You're simply filling in the third and final given statement, which you'll notice is provided above. With statement number 4, it's important that you're careful with how you word this, because we know the measure of angle DBC is 40 because of a combination of what's stated in step 1 and in step 3. We know the total angle up here is 80 degrees. If it's bisected, it must be cut in half. So our reason needs to reflect that. Finally, if we complete the proof the way that we should, we're going to be comparing angle DBC and angle Y. Why are these two angles congruent? They're congruent for the same reason any other two angles are congruent, because they've got the same measure. For the second question, you're given a diagram that we're told is trisected. So what you should be able to apply to this diagram, since it's trisected, is that all three of these smaller angles are going to be the exact same size. That's what it means for an angle to be trisected. If angle ABC is trisected, then there are 3 congruent angles as a result. Angle DBC, angle EBD, and angle ABE. You'll notice I've got tick marks on each of those to remind me that they are congruent to one another. For the first part of this problem, it says that angle ABE, which again you can locate right here in the diagram, they tell us it's 21 degrees, 13 minutes, and 40 seconds. The size of DBC has to be exactly the same, since, as we just stated, this original angle is trisected, and the two angles in question for part A are each 1/3 of the original large angle. Not meant to be a trick question, just simply making sure that you understand what the word trisect means. For part B, we're given the entire angle measure, angle ABC. The entire angle is 105 degrees, 18 minutes, and 42 seconds. Since they're asking us to find the measure of DBE, which again, if you go back to this diagram and you take a look at how that relates to the larger angle, you'll notice it is 1/3 of the total size. So how do we find measure of DBE? We simply take 1/3 of this measurement that we're given, and if you do that, you'll get 35 degrees, 6 minutes, and 14 seconds. Last piece, part C. They give us the measure of ABD, and be careful because the measure of ABD actually occupies 2/3 or 2 slices of this angle ABC. So as a result, if we're going to be looking for the measure of DBC, which, as we stated earlier, is 1/3 of the total measure, then we'll need to cut this measurement in half. And you'll notice there's a little bit of converting that we do too, because half of 15 is 7.5, so we have half of an angle to convert. And so when everything's said and done, we've got 7 degrees, 35 minutes, and 15 seconds. For question number 3, you've got to write another proof. You can write it in whatever kind of format you want, but ultimately we've got to figure out or prove that angle VYZ is an obtuse angle. Now initially, you are not given any of the measurements or data that I've got written down here. You're just given the diagram. And so what you need to realize is that you can't simply look at this angle and proclaim that it's obtuse just because it looks like it's obtuse. So what we'll do is we have to start by saying and listing some of the things that we do know and can actually conclude from the diagram. So somewhere in the proof I've got to see that you have listed this angle VYW as a straight angle, which makes it 180 degrees. That allows you to set up the equation that I've got over here on the left. And so what we're doing here is we're taking the pieces from this straight angle above, we're combining them because together they create the 180 degree angle. So when we add the two angles, the one on the left and the one on the right, we must get 180 degrees. If you can set that up, the next couple steps are just simply solving the equation, and that's where I get my x value. X is equal to 35 in this case. Once I know that, I come back to my proof, I take that x equals 35 value, and that allows me to come back and then plug in values for x in these equations or these expressions above. So once I know that x is equal to 35, I substitute into VYZ. That gives me a measurement of 103. And finally, if I know that it is a 103 degree angle, then it has to be obtuse, because an obtuse angle is larger than 90 degrees but less than 180. So clearly that would qualify as an obtuse angle. For the fourth and final question, we are asked to find the value of x that makes M a midpoint, and we have to find the length of segment OP. So the first thing we do here is realize that if M is the midpoint, then the segment over here on the left and the segment over here on the right have to be the same length. Otherwise it would not be a midpoint. So for those two segments to be congruent, they must be equal. So what you'll notice is I simply take the two expressions that represent OM and MP and I set them equal to each other. Once that's set up, I carefully solve for x, and x is equal to 1/3, which answers part A. The second part is to find the length of OP, and once again realize that OP is a segment based on the notation that's being used in the diagram that you're presented with. In order to find the length of OP, I have to take the value for x and plug it back into each of these segments. So you'll notice that's exactly what I'm doing down here. I'm going to take OM and plug in 1/3. A third of 15 added and add 10 more gives me 15. I should come up with the same amount for MP, which I do, but they should match since M is a midpoint. 15 and 15 gives me 30. Therefore, the length of OP, the length of segment OP, is 30 units long. Finally, if you're interested in the bonus, here's the question, and here's a brief explanation. You're asked to find the measure that's formed when the clock reads 7:15. So there is a tremendous drawing of a clock, and you'll notice the minute hand is on the 3, the hour hand not quite on the 7. We'll get to that in a minute. But because this clock is circular, we note that there are 360 degrees for an entire rotation around that circle. Since there's 12 digits around that circle, there's going to be 30 degrees between each set of numbers, because 30 times 12 is 360. So when I look at my drawing, I know that there are at least 1, 2, 3, 4 digits that are spanned by this 7:15 time frame. So I've got at least 120 degrees that's already accounted for from just that span. But since it's 7:15, the hour hand's not on the 7 anymore. It's actually almost working its way to the 8. So that way when it's actually 8 o'clock and the minute hand gets all the way up to the 12, then that hour hand is on the 8. It's our job to figure out exactly where is the hour hand between these two numbers. So, since 15 minutes of the hour have passed, it is reasonable to conclude that 1/4 of the hour is done. which also means 1/4 of the 30 degrees is going to be spent between that 7 and 8. So I've taken 1/4 of 30 degrees, that gives me 7.5. I tack that on to the 120 that I know is already between that 3 and the 7, and I've got 127.5 degrees. Last thing I do is I convert the half degree to 30 minutes, and I've got my final answer. So 127 degrees, 30 minutes. That's it for now. Good luck with the rest of the chapter.